Hello, Stefan.
Hey.
I'll switch to English now, so that he understands. We're going to have two presentations this evening, both of them by Stefan. For those who don't know Stefan, he's a living Kafka celebrity. He's teacher on Udemy. He has 7 courses on Kafka and 6 courses on AWS. And he's teaching and he taught tens of thousands of students around the world about Kafka. He's currently a member of Kafka Summit Committee. Little Bird told me that he has also a presentation on this year's Kafka Summit in London. And I think he has a thing or two to say about Kafka. So, Stefan,
thank you.
It's your turn.
Okay. So I'm going to speak in Croatian now. Just kidding. It's going to be in English, okay? So I'm sorry if I speak too fast. Just show me your hand. You're like slower, please. If you don't understand anything that I'm saying, I'm sorry. Hopefully it'll be okay. So I'm Stefan. So it's actually, before I start, it's actually really funny how I meet Ivan. So did he tell you in Croatian how we met or anything like this? No. So as you said, I'm a teacher on Udemy for Kafka. My Kafka course is about there for almost 2 years now. And I think maybe in July 2017, so almost 2 years ago, Ivan was kind enough to help me out on the course to answer students' questions. So Ivan is actually still today helping answering students' questions. We're talking about, like 5 questions a day on that course from students. So this is how we met, and I was in Australia back then, and he was in Croatia, and it was through this course that we met, and we kept in touch all that time. He's like, why don't you come to Zagreb? I've never been to Croatia, so I'll come back for sure. We do a lot of good food, and discovering the city is beautiful. I really like it. But that's like such a funny encounter. Just sometimes, just before I get started, like it's crazy to think that some of the people you meet online or just through random situations and just say yes, let's try to do something, like end up me being here in front of like 100 people. Like it's insane. So thank you so much for organizing this, Ivan. Hopefully you'll re-invite me after this if you guys like it. But thank you so much. So I'm thrilled to be here. I've had a pretty international journey with Kafka. Started in Australia and did the Kafka Summit. This presentation actually at the Kafka Summit San Francisco in October last year. So you're going to get a replay. Sorry if you already watched this on YouTube or whatever. Who has watched it on YouTube? No one? Great. What is YouTube? I don't know. What's the Croatian YouTube? I don't know. But yeah, so this is from the Kafka Summit. We're having a bit of a Mac flickering issue with the screen, and I don't want you to become crazy at the end of 30 minutes of presentation. So this one is just slides. I do have the presentation with demo coming next, hopefully. That should have been the first one, but it's the second one. But guess what? It's the better one, the one after it. So you have to stay. And there'll be like a small gift as well if you stay through the presentation. I'm not going to tell you why, then you have to stay, because if you leave and you don't know, then you're going to think about it all night long. Okay, that's enough yapping. You guys understand me? Yeah. You guys afraid of me? Yeah. No? There's like a whole seat.
No, we are safe here.
You're safe here. Okay. If you feel like coming closer after a beer, after the first break, just... Okay. It's good to see the good energy, so thank you for coming for this. So this is a presentation on Kafka security. So just before I even get started with Kafka security, who here has heard of Kafka? Okay, at least you know why you're here. Who here feel like they're a bit beginner at Kafka? A few people? Beginner. Yeah, a few people? About half the room? Okay, so I'll remind you what Kafka is in the next session. Should have done before. But it's basically a PubSub. If you've heard of queues, Kafka is like a giant distributed queue, a bit like that. So that's the idea. So now we're going to talk about securing Kafka, which is not the first thing you would usually do when you start with Kafka, but that's what we'll do in this talk. Okay? All right, let's get started. Okay, so this was me. I was in Australia and I got started with Kafka and I was having a lot of fun. And 2 months in of learning Kafka, my boss came to me and he said, Stefan, you've got to implement Kafka security. That was in 2016. And that was my face back then. I was really afraid. I was like, I don't know anything about Kafka, I know nothing about security, and I've got to implement Kafka security, so I had a good beer and went to sleep and decided I'll do it tomorrow. So that's my journey, and that's, if you ever get through this, then I want you to think about this moment and say, someone has already done it before, it's doable. So who am I? So Ivan introduced me really well, but I'll just do it again. Stefan, I'm French, but I lived in the US, I lived in Australia, so if you hear mixed accents, that's why. I don't have a French accent on naturally, I can make it on purpose. But I don't want to distract you too much, so I'll try to remain with this. I have my own company now, so it's called Data Cumulus, small shop, and I'm also an online instructor on Kafka on Udemy, so Ivan said like 25,000 students online, 7 or 8 courses on Kafka, a wide range. Curious, who here has taken my course? Oh shit! Can I take a picture? Can I take a picture? Who has taken my course? Oh, that's so nice. Okay, thank you. That's actually I'm really happy, you know, because I don't get to meet students very often. It's all online. So thank you so much for those who bought it. For those who don't buy it, you'll buy it one day, maybe. So I love Kafka. I really think it's a cool piece of software. So I did full deployment with security. I'm writing some cool POCs online, blogs, all that stuff. Kafka series on Udemy. I'm thankfully very honored to be a program committee of Kafka Summit 2019. So New York, London, SF, I helped review papers, so 800 papers to review for London. I'm going to speak in New York, I'm going to speak in London as well, 2 different talks. San Francisco isn't open. If you are doing something cool with Kafka, please submit something. It's a really cool event, it's some really cool things happening. And if you don't get the chance to do it or go watch online on YouTube, there's some really good information usually. Find me on GitHub, LinkedIn, Medium, Twitter, and Udemy. So a lot of channels, you can connect with me. I'm somewhat active on any of those, but feel free to connect with me in any way or ask me questions. I don't bite, although the first rank might seem like so. So, okay, who here is using Kafka in production? Okay, a few hands. Amongst those using Kafka in production, who has secured Kafka? 2! Oh, it's okay, you can go for a beer and you'll be back in 30 minutes. No, it's awesome. So, basically, if you don't secure Kafka, you're exposing yourself to risks, like big risks. And obviously security is important, but how important and what are the risks? This is the kind of things that we wish we'd know before we go into implementing security. So I ranked these risks in order of gravity. So number 1 is the okay, number 5 is really, really bad. Alright? And you'll see number 1 is actually pretty bad already. So number 1 is I can read all your data. Okay. So think of a company. If you're a small startup, why not? If you're a bank, who knows? Number 2, I can write to any topics, any way I want, so I can break your consumers. I'll just send what's called a poison pill. I'll just send a message that's cannot be deserialized correctly, and your consumers cannot read it. Boom, they crash. And if done correctly, everything crashes. Downtime across your organization, you're going to lose a lot of money. First one is data leak, second one is money loss. Third one, if you're running across an unsecure network, you can intercept network packets, so just PI data, if you do that with Kafka, I mean, you can literally see things coming through. Fourth one, there's a command, no one knows it but me, so it's good. But I can delete all your data in Kafka in one command. I don't need SSH, and I don't need you to enable deletion of topics, but I can still do it. So that's how insecure it is. What's worse than losing all your data? No one knows. It's if you're using Kafka Connect, most likely your database credentials are going to be in Kafka, in plain text, unsecured. So on top of giving me access to Kafka, now I get access to all your production systems. So now it's getting really, really bad, right? So usually when you see this list, you kind of want to secure Kafka at some point. Okay, so you need Kafka security, and that's important, and that's what this talk is about. Now I'm not going to try to make this super boring. Kafka security is boring, so I'll try to make it as okay as possible. You don't need to be a security expert to understand what I'm going to say. I'm going to be using very simple words. If you are a security expert, you may hate me because I may say wrong things or explain things too easily. Don't worry, I'm not trying to offend you. I'm just trying to get the point across, okay? So, what's Kafka security? There's 3 things in Kafka security. The first one is authentication. The second one is authorization, encryption, sorry. The second one is authentication. And the last one is authorization. So in this presentation, we're going to view all these things one by one, understand what it means for Kafka, all that kind of stuff. This is familiar, right? This is not new. This is IT in general, for any system, not just Kafka. Okay, so encryption in Kafka. So encryption means usually involving some kind of SSL certificates. For the purist, TLS, the new word. So it's similar to when you go to your website and it's HTTPS, S stands for secure, or SSL or TLS, whatever. The idea is that your communications are encrypted with the website. If you go on the website, such as PayPal, and pay with your credit card, you need to make sure you have the green lock, otherwise your credit card data could be intercepted and it could be really bad. So the idea is that when it's not SSL encrypted, when it's in plain text, you send a super secret message to Kafka, and someone along the way could be intercepting that message. That's bad. But if you're using security, then basically you send encrypted data, and I'm not going to go through exactly how that works. But the idea is that only you, the sender, and the broker are able to read that data, making effectively an encrypted connection. That doesn't, someone can still intercept that data, but the algorithms of encryption are made so it's impossible to decrypt at scale. Okay, it will take too long to crack that. That's basically how the web works today. Okay, so concretely, you need to create something called a certificate authority. So it's basically someone who's able to issue SSL certificates. So then you generate certificates for your brokers, you sign them, you make sure your brokers and the clients trust the CA root. That means, okay, I trust whoever wrote these certificates, whoever authored them. And then when you're happy, you put this blob of configuration in your Kafka brokers and your sets. Okay? So very simple. It's kind of like the same when you have a website. You go to a CA, usually a public website. Could be Let's Encrypt, could be VeriSign, could be whatever. They're going to issue you a certificate. And because all web browsers, all Chrome browsers around the world trust 10 or so certificate authority providers, the public ones, then your certificate is trusted by your browser and you can connect securely to the website. It's the same with Kafka, except this time usually you own the CA because your Kafka cluster is private. Okay? You can stop me, by the way, if you have any questions, but don't stop me too much. So in the real world, what is the impact of doing SSL? Who's heard of zero copy in Kafka? 1, 2, 3, 4, or zero copy overall? Okay. So SSL, basically you lose the zero copy optimization. That means that you lower the performance of your brokers. How much lower? 30%. It's never like a definitive number, right? But it's some performance loss. Kafka is really, really performant. Kafka with SSL is less performant, but still really, really performant. Okay? So you lose the zero copy optimization. It's, yes?
Does the number of messages impact the time that it's loaded?
Yeah, it's going to be basically based on the payload.
Based on payload?
Payload size. Payload size. Payload size. So think of like you're sending 5 megabytes of encrypted data. This is how much needs to be loaded into the JVM to be decrypted and to be put into the disk. So it doesn't really matter if you have 1 million messages in there or 10. It just matters the size of the payload. Okay? So basically zero copy is when the thing that makes Kafka really good. So Kafka, they tell you it's a really performant system. It's like, it's amazing. The reason it's amazing is because of zero copy. So it receives data from the network, and Kafka is running on a JVM. And instead of loading that data into the JVM, it uses something called zero copy, and it's able to tell the kernel to take that data from the network and put it directly into the disk or the page cache. And the idea using these things is that it doesn't go through the JVM, so you save in copy. That's what it's called, zero copy. You save in copy, and because you're not copying data from different buffers, then you're gaining in optimization and performance. That's basically what makes Kafka good. So when you use SSL, though, because you have to decrypt that payload, you have to copy it. For now. I think it's going to get better eventually. Also, because you start decrypting data, the heap usage will increase. So Kafka is like usually 4 gigs of heaps. You can go to 6, 8 gigs of heap with SSL. That's about it, but it's good to know. The CPU usage will increase. Now, let's be honest, SSL is CPU intensive, but it's not that CPU intensive. Like modern CPU can do 500 megabytes of encryption, decryption per second. So that gives you an idea of what a full CPU can do. So it does increase CPU usage, obviously, but not too much, but it does increase it. And SSL, it's encryption, but only in flight. Okay, the data on your broker still sits unencrypted. That means that if someone basically SSH'd your broker and looks at the volume in the disk, it's going to find your data. It only guarantees that in flight, it's secure. Make sense? All right. Haven't lost anyone here. So what about end-to-end encryption then? What about like having the data encrypted everywhere? The idea is that your producer would encrypt your data, then send that encrypted data over the network. Even over plain text, no need for SSL here. Kafka would store that encrypted data and then send the encrypted data to the consumer, who would decrypt it at the end. So it's a bit more advanced concept. The idea is that here it's not SSL encryption, it's literally producer-based encryption sent all the way to the consumer. So how to do this? Apple has it, but they don't tell how. It's usually how Apple works anyway. There's some open source stuff online, and I'm working on something, but I kind of let it go. But there's ways to do encryption in Kafka, but it's really hard, okay? End to end. But it's possible. So if you're a bank, or if you're have very, very strong security requirements, you can do it. Okay, so encryption done. Next step, authentication. So authentication to Kafka is basically your clients, they need to prove to Kafka who they are, right? They need to have their identity. So authentication, when we think about it, easy to understand, username, password. When you go to any website, you visit it, you don't know who you are, and then you log in, you put your username, the password, the server verifies who you are, and then the server says, okay, this looks good, I know who you are, you're authenticated, and you have an identity. Very simple, right? So that's how simple it is for websites. It's not like that for Kafka, it's way more complicated, but it's the same idea. So Kafka security has many different ways of doing it. The first one is called SSL authentication. So who's aware of it? Who knows SSL authentication? 2, 3, 4, 6, 7, 8. Alright, so we've seen SSL for basically encrypting and decrypting data when you connect to a website, just having secure communication. But there is a second thing called SSL called mutual authentication. And mutual authentication means that the clients also are issued SSL certificates. So now the brokers have an identity, and the client also can prove their identity to the broker using the same mechanism, and effectively there's mutual authentication. That's how it works. It's a bit complicated, but it works. Then there's SASL. SASL stands for Simple Authentication and Security Layer, and SASL is not simple. So SASL has the first little flavor of it called GSS API, which means Kerberos, which are horrible words. Microsoft came up with a genius idea, and they said we're going to call this Active Directory, which is much more better sound to the ear. And basically everyone with a Microsoft Active Directory has Kerberos in their infrastructure. And that's the only commercial implementation of Kerberos, by the way. I mean, there may be another one. And then there's the Linux Kerberos, the one from the MIT, which is really hard to use. But it's kind of like the de facto standard for now. SSL plain, which is like username, password, but it's not really good. SASL Scram SHA 256 or 512, which is basically passwords and Zookeeper, so username, passwords. This one is what's used by Confluent Cloud, for example. So if you open up a Confluent Cloud, like manage Kafka on the cloud, you would get this kind of security mechanism. And then you get SASL OAuth bearer, which is for OAuth 2. So if you have like a OAuth 2 login in your company for whatever reason, you can leverage that now in Kafka. But I haven't used it myself personally, so I won't be able to answer many questions about it. But it's possible. And then you can write your own and contribute back, and it's a really tough thing to do. Okay, and real world advice. So if you have one of these things in your organization that matches what you have, if you have Microsoft AD in your organization, use it already. If you have OAuth in your organization already, use it, right? If you use SSL mutual authentication, although if they're purists here, they will tell me otherwise, but it's hard to revoke authentication. So when you issue an SSL certificate, I think you probably all know it, you issue it for like 180 days or 1 year or 10 years, and it says, okay, this is signed valid for 10 years, and it's really hard to revoke it because it's signed in 10 years. Someone has the proof it's valid. So there's ways to revoke it, but it's really hard. That's what makes it not a very, very good authentication system, because then if you want to revoke someone's access, you got to wait 10 years. Not very good, right? There's initiatives called like Let's Encrypt. Probably heard of it. It's 90 days, and they're talking about reducing it to 1 day, but I think we're not there. No one has the automation present. But anyway, SASL, it's not simple, but maybe you're great at SASL and it'll be simple for you. And Kerberos is super, super, super hard to make right. And when it doesn't work, you don't know why. And it's like the most cryptic errors I've ever seen. It's kind of like you need a PhD in Kerberos to understand the errors. So when you do set it up, though, you know your security is rock solid because there's so many checks and stuff like this, you can't get hacked. So setting up this piece right here, the security part, the authentication part, is by far the hardest. SSL, easy. Authorization, easy. Authentication, super, super, super hard. Okay? I know this is something the Kafka project is interested into making easier, and I'm the first one to make it easier. Like, I have the knowledge in this and it makes sense to me, but for people it's like, it's so scary. It's gonna get better, but for now, this is what we have. Okay, so just to show you the hardest one, this way we're done. It's like, it doesn't get harder than this. For Kerberos, how does that work? You create Kerberos or use Active Directory, then you ensure the Kafka servers have the correct host name, so URL, CNAME, and host name, pointer records as well. You generate credentials for the brokers. For each of the broker you have, you need to generate one credential. So if you have 100 brokers, then you should have 100 principal names, it's called. Then you generate key tabs from this credential. It's basically a username password in a weird way that makes Java happy. And then you create something called a JAS file. It's a beautiful thing like this that looks like nothing. And there's like a few parameters, they're dynamic. You don't really know what they do, but you just put them because everyone wants it. And we're not done. Then we start with Kafka with Java options to reference the JAS file. We add properties to Kafka. We start Kafka, and then you pray. and word of advice, if it works the first time, it didn't work. Trust me. Or if it does, just call me and we'll sign the contract together. Okay, so real world tips. Turn on debug, go slow, ensure CNAMEs and PTR records are correct, and you just try again. Like sometimes it's better to just retry again and redo the documentation than trying to do little tweaks here and there. You'll get the hang of it, I get the hang of it now, but it's quite tough. And then once you get it working once, don't like say, yay! So automate it. Make it work twice, 3 times, 10 times. Because the day you leave your company, they need to be able to reproduce what you did. Don't leave with that knowledge. Automation is super, super important. Okay? Still there? Yes. Not too bored? Security, I know. So we're almost there. We got 2 down, and now there is authorization. Okay. So authorization in Kafka is, okay, Kafka knows who are clients. We can give them identity. You're Alice, you're Paul, whatever. And so you want to say, okay, Alice can view the topic finance and Bob cannot write to topic trucks. That's kind of the basic rules you want to have in your cluster. And so for this, you have ACLs or ACLs or whatever you want to call them. They're basically access control lists, and they determine who can do what in your system. It's very simple, very easy to understand. This is the kind of permissioning we all have. So where are they stored? They're stored in Zookeeper. So all the data that's saying who can do what is in Zookeeper. So the great news is you get a secure Zookeeper now. Yeah. So it's not easy, because now you get a secure Zookeeper and Zookeeper. If you think Kafka was fun and secure, wait until you get to Zookeeper. There's no documentation on it. No, I'm not kidding. Usually the best way to secure Zookeeper is to just get the network policy to just say you can talk to Kafka and just lock it down. That's the way of doing it. Or you write your own authorizer, and that's another piece of fun you may have want to do, but it's possible. So for producers, how does that look like? That looks like this. You want to add permissions, so you run this beautiful command, which is basically saying, hey, you're a producer, you're going to be able to write to a topic. By the way, here's where Zookeeper is, and it's going to do its thing. And there's a shortcut to just manage producer, and this will make it a little slightly easier command to do. Very easy. So producers, when you think about it, when you're a producer, you send data to a topic, that makes sense, right? You just need to be able to write to that topic. Now for consumers, you need to be able to read from a topic, but you need a second thing. What is it? Offsets? What do you mean by offsets? Yeah, consumer group is right. So offsets, I guess. So basically the idea is that when you read in Kafka, and sorry for the beginners, we'll see this later, but when you read in Kafka, you read in consumer groups, and your groups, they have an identity. It's like, hey, we're application A, hey, we're application B. And so the right to say, hey, I'm part of application A or application B is also a security. You don't want someone you don't know claim they're your applications and start reading with you and stealing data from you. You know? So when you're a consumer, basically you need to add a thing for read for a topic, but also a write or read-write for a group. So you need to be able to read from a topic and also access a specific consumer group. That's a bit tricky sometimes. Shortcut though, there's a minus consumer, and then you read from a topic, and then you also say I have access to this group. Yes?
Read the second one, the second just to write. We wouldn't be unable to read where it committed all things before.
So it's one of the most discussed things on the mailing list. They started with write, and they say, yeah, but aren't we reading from it? Then they added read, but they say, aren't we writing to it? So now we have both, and both do the exact same thing.
But just for groups.
For groups, just for groups. So for groups, reads equals writes. There's discussion about it. It's quite funny if you want to read it. I'll give you a link. But yeah, that's a good question. It kind of makes no sense. Whatever. They should have just had their own ACL. Anyway, I'll talk about it in another day. Okay, and then there is my project, because I want to make things a bit more simple. So instead of running these ugly commands, I wrote something called Kafka Security Manager. Check it out if you're interested, if you do Kafka security. But basically the idea is that why would I want administrator to talk to Zookeeper and add and remove stuff on the fly? It's not very secure in that way. Why won't I just have a source of truth, like a CSV file in GitHub, S3, Bitbucket, whatever on the file system. And so that's the source of truth. And every 10 seconds I'm going to synchronize it with Kafka and make sure that's exactly what's in Kafka. And so if there's any discrepancies, it's going to be fixed. So it prevents attackers, it makes management easy. If it's in GitHub, people who edit that CSV, they have to do pull requests, there's approvals, there's commit history, and on top of it, you get notifications to the console or to Slack, just to be aware of what's happening. So it's quite an extensible project, but one, when I go to my clients and implement Kafka security, I have to use this because it's way easier to read a CSV than doing all these crazy commands. Okay, so check it out. Okay, real world tips on ACL. So authorization denials will be logged as info on the Kafka log. So if your application can't talk to Kafka or is denied authorization, you figure out what's wrong by looking at the log and seeing where the denial happened and tell you, hey, you need to describe permissions on this. Okay, so we need to add. The brokers must be super users. Otherwise, if they're not super users, they can't be brokers. It's a bit stupid, but that's how it works. Careful with this command, this thing called allow everyone if no ACL found equals true. That means if there's no ACL defined from a topic, let everyone in. It works when you're transitioning. It doesn't really work when you're production done with it, so be careful. And ACLs can be applied to anything and many things. Create, read, describe, write, describe configs, after configs, create. I mean, it's a bit crazy, and it's not well documented, but you basically get things like this. And then you have wildcards supported in Kafka 2.0, which is super helpful if you get Kafka Streams, because you can save a lot of trouble writing ACLs just using a small wildcard. Okay, so summary, what does it look like? Like a nicely secured cluster. You have SASL and SSL at the same time, so encryption and authentication. Your Kafka cluster is also fully secured. Your brokers are authenticating with each other, they're talking securely, and then they're talking securely to Zookeeper as well. That's kind of the idea of how you want to secure Kafka cluster. Make sense? Alright, so encryption, authentication, authorization. Are we done?
Probably not.
Probably not. That's smart man. We're not done. I figured, okay, I've secured the cluster. And he said, great, now you secure the applications. And that's the kind of things you don't see coming. But that's Kafka security. You do your broker security, you do your zookeeper security, and what you don't see coming is the 1,000 applications you have to secure as well. Maybe not 1,000, but you get my point. And that can take a while too, because you need to think about like, how do I secure 1,000 applications? How do I deduplicate myself? How do I share my knowledge? Things that no one wants to learn. I'm doing it right now, but you know. So I'm going to tell you some secrets and some tips. So Kafka client security is the real challenge, because if your cluster is secured so well, but no one can use your cluster, maybe it's secured too well or you didn't do your job right? People need to be able to connect your cluster and do their thing. So if you have Java clients, it's easy. If you have non-Java clients, somewhat easy. You should use librd Kafka, and even though not very easy, but it's possible, but it's not easy. And then there's people challenge. So if you're a Kafka admin, meaning there's a Kafka admin type of role, and I'm the Kafka admin, I set up Kafka security. I know everything about security. I don't want to do the developer's job of doing their stuff, right? And as a developer, they're like, no. Right? So you need to find like this in-between points. Not just on technical challenge, but also on people challenge. So client security in Java looks like this. So you're like, okay, just put these settings and off you go. So what's the probability of them messing their settings? High, right? Like typo or wrong copy and paste or missing an at or wrong. I mean, you have no idea. So many things can go wrong in that setting. So you need to find a way to make this right. So it's not fun, it's not easy, it's error prone. To a developer, this means nothing, right? So basically, Kafka clients, and it's more like a philosophical discussion, but basically they're not tailored to your security needs. So Kafka clients have every option in the world to connect to your cluster. They can do Kerberos, plain, Scram, OAuth, SSL mutual authentication, right? But in your enterprise, you're not crazy. You're just gonna have one security mechanism, just one. So why give your clients the ability to do everything when you need them to do one thing, right? Because every client's configuration will look the exact same. The exact same. So when you think about it, when you see all these things, what does that make you think of? There's no wrong answer. Sorry? Common repository? Yeah, exactly. So you need like a library, right? Doing the same thing over and over 1,000 times, that's a very good candidate for a repository. So you write your own Kafka clients. Super easy to do, to be honest. Like any Java dev can do it. But then it looks nice. My corporation, Kafka Producer, you need to give me a bootstrap server, a key serializer, a value serializer. You need to have SSL enabled, yes or no? You need to have authentication enabled. Yeah, give me your key tab, give me your username, I'll take care of all the crazy blob for you. Give me the schema URL, give me some extra properties if you want, batching, compression, all that stuff, whatever, and then build. And behind the scenes, the client library to take care of everything. That's nice. As a developer, I'll tell them enable security. Okay, I'll just set this to true. Done. Like no one can complain about it. But if you don't do that, you're going to get a lot of friction and a lot of pushback in your company. So make that effort. Hey, so standardized application, no more copy and paste errors, centralized debugging, and reduced learning curve for devs. And for me, the policy was if you don't use my code, I'm not helping you. So if you get errors, that's your problem. I'll give you a solution already. I'm not a nice guy. Okay, number 2, if you want to take this further, this like standardization further, why don't you create a base Docker image? Who uses Docker here? For deployment? Just less, okay. Let's use Docker for deployment. Do it, base Docker image, right? Embed a modified Java trust store. Add SSL certificate script for retrieving them securely from your store. Get credentials from your secrets manager, maybe Amazon or Vault or whatever you want. Do Kafka environment switches. I want to be in prod and dev and test. I want to have security, not security. Like, do some groundwork. Like, make it very flexible. Bootstrap server discovery, schema registry discovery. Like, think of like the number of people who don't give a crap about all these things, and they just want switches and configs. Like, think about all these good things you can put in a Docker image. and make everyone's life so easy. And then do the same for Kafka Connect Schema Registry, like really make it a common set of standardized application in your company. And this doesn't just apply to security, right? It applies to everything you do in your company. But it's really nice to think about it this way. Kafka is a good example because it brings you so much ahead in the game. Number 3, a bit boring, but Kafka checklist before going to prod. That sounds like nothing. I hate processes where startups, we're lean, we're agile. But this helps a lot. What's the application username? What are the ACLs? Are you using the clients? Is it running in a Docker container? Do you have quotas? Is the application monitored? Alright, go. You can run with it. But just a simple checklist usually goes a long way to making sure that the code you have in production is of quality, is running, and won't crash for whatever reason. Okay? And, okay, I want to do security. Yay, Stefan, you really motivated me. So read the docs, but they're horrible, but still read them, you have to. The docs is a source of truth. Read some blogs. So I wrote a blog called Introduction to Kafka Security, which looks like my presentation, but if you forget everything the next day, then read the blog. There's something on the Confluent blog as well. Video courses. Confluent has some YouTube videos. I'm putting them because I'm nice, but my course is better. You can do my course and we do it together. And that's it. Thank you. Any questions? Yes, in the back.
The first one is if you want to get the encryption at rest, basically the only way to do it is end-to-end encryption.
Yes.
And the second question is regarding dropping the database.
Sorry?
The second question is regarding the dropping the database you mentioned.
All the data from Kafka.
Deleting all the data from Kafka?
Is the command issuing config source to set retention period or something short, or? Maybe.
Yeah, it's kind of that. So when you secure Kafka, you basically prevent people from changing that setting.
But can you configure your workers not to listen for the config commands only? Or?
No, not yet. But that's like security when you think about it. Right? So you can do a PR and say, you know what, I want to disable overriding configs using Zookeeper, because as we're talking about is overriding configs using Zookeeper. There's no way to disable that right now, so you cannot go along with it if you use Kafka 2.0. But if you're really motivated and make a case for it, I'm sure you can add that config. You're just going to have to go through a kit process.
Thank you.
But yeah, keep that to yourself. Question, there was a question here.
Yeah, so first off, I never really use Kafka, so I'm just...
So you're going to stay here for the next presentation?
But question, so are you supposing that, like in what you showed us, that the network, kind of the clusters running in is like open to the outside? Like, I mean...
So it's not, so it could happen. Think of like Kafka cluster replication, your IoT, think of like a more like open in the internet type of network. That's number one. Number two, it could be within your own on-premise. It could be within your own AWS cloud, even though this is supposed to be secure and this is supposed to be safe from attackers not getting access to the routers, whatever. Some companies, usually banks or whatever, they do make it a strong requirement to have encryption everywhere, no matter what. So even their Postgres database would be SSL encrypted, even their website would be HTTPS enabled. And so they say our Kafka is nothing like it's not different than anything else. It's an application. It has an SSL capability to do it.
Okay, but if I was just running Kafka from a startup and I'm running it like in my
Then you can
internal
just do-
network
you can
with
just
my
do-
internal clients, I wouldn't really need to care about a lot of this.
Then you could just implement the authentication and authorization piece, but you run the risk of, but yeah, then you'll be fine.
Okay, and just quick question about the authentication stuff. So I didn't really understand, like, why can't I just use like a token or like a username? Because like I would connect into a database. Like, why do I need certificates just to connect my clients to the cluster?
It's like a token. It's really like a token, like a database. It's just distributed, but it's just a token. The way to obtain that token depends on the way you do authentication. So if it's SSL authentication, then it's not exactly token based. But if it's like username and password, then yes, you're going to acquire a token and you're going to authenticate to Kafka. If it's Kerberos, that token you obtain it from a third-party store. 1 second, I'm just going to, yes.
Securing Zookeeper is possible, but hard? Or?
Yeah, so securing Zookeeper, 2 ways, 3 ways. Number one, network, just network. So restricting network rules to your Kafka brokers, that kind of stuff, like just basic security, restricting SSH access, restricting network traffic from brokers, and limiting your risks, basically. That's a way. It's not the recommended way, but it's a good way to get results easily. Number two is basic. So Zookeeper has a way to have basic, but you need to hardcode all the username and passwords in Zookeeper. But when you think about it, you don't need that many usernames in Zookeeper, you just need one. Usually in Kafka brokers, you never should allow your clients to connect to Zookeeper. So basic is a way. If you are a company that's more like enterprise-like, Kerberos, again, is the way. So there's a Kerberos module for Zookeeper, and usually when you have Kerberos for Kafka, you have Kerberos for Zookeeper, and it makes companies happy because it's the same kind of mechanism. Yeah.
In practice, what people learn first method?
But so I said, like, first one if you just want to be quick and easy. Second one if you're just a startup and you don't have Kerberos. Third one if you're a big enterprise and you have Kerberos already, like Active Directory, you just use that. At the end of the day, it's all possible. There's no good and bad. It's up to what are you as a solution architect want to choose. That's it. Yeah. But good question.
Okay, if I may interrupt.
Yes.
If you have any questions, then maybe we can continue in the lobby because here we are not allowed to drink, so give a man time to drink a beer. Okay, and, he has one more presentation.
Yeah, you stay here. There's a small president. Hopefully we can do it without killing your eyes. But thank you so much. This is the kind of presentation you're looking into. So the idea is this presentation actually was a blog post that I did on Kafka, and I think it's like the most read or shared blog post on Kafka on Medium, at least. So it's long. It's like 17 minutes of read. So it's like I wrote a book. It's a book of like 2019. Otherwise, it'd be much longer. But yeah. So this is a big one, and so I want to do a presentation of it, doing a live demo. The code is on GitHub. The blog is on Medium. So if this is going too fast, you want to go back through it, or actually do a deep dive in the code, you can do it. This is not going to be a huge deep dive in the code. I don't want to do like a presentation just about one technology. What I want you to take away from it is like, we can do this with Kafka, or like, it looks pretty simple, or it makes sense. This is more the kind of stuff I want you to do. The code itself, please take your own time to dive through it, and I'll show you the important parts of it, but don't think about it too much, okay? So even if you're not a programmer, that's fine. Okay. So you know me, and so it's a fun presentation. So this guy is so Michael Knoll. He's a product manager at Confluent, and he allowed me to use this quote. But when you use Kafka, but for example, if you were to cross the street, would you do it with information that's 5 minutes old? I don't think anyone in this room would. So it kind of makes you do real-time everything. Real-time everything. And so that's where Kafka is. Your business is better if it knows what's happening now versus if it knows what's happened 5 minutes ago. And that makes a lot of sense. Not just crossing the street, which is a life and death type of matter, but also in-store sales. Like if your customer is in your store right now is the best chance for you to sell him something, or to learn about him, or do anything that's relevant to him, versus 5 minutes later when he's left the store. Or if your sensor is going off the hook and it takes 5 minutes in your nuclear plant to reach HQ because a batch process is running, that's bad, right? 5 minutes, it could be life and death matter. So Kafka is not all life and death or whatever, but it gives you an idea of like, real time is good. If you want to enable real time, Kafka is a great technology to do that. Okay, hope I convinced everyone that Kafka is great. So it's more of a personal story. So I told you I'm a teacher on Udemy, and so I get pretty frustrated with Udemy sometimes. But reviews are released every 24 hours. That was when I wrote this. Now it's every 12 hours. They did twice as good. But still, every 12 hours, every 24 hours, I get the reviews of all the students who posted reviews. And that was when I was beginning, and I was very frustrated with this. I was like, why am I receiving, like, people post a review on the website, like, why am I not seeing this? There's a few reasons, but at first I was like, why am I not seeing this? And so I was just like, can we make this real time? Like, can I try to reverse engineer what's happening on their end and kind of transform this into a real-time process. So it's a fun one because it's actually applicable to some website, but it's not like any company one, and I don't work for Udemy. I'm just an instruction on it, so it's a freelancer type of thing. So all this code is fictional, and all that I'm going to present is not based on what they have, it's based on what I think they have. Okay? Just a disclaimer right here. It's just me having fun. So as I said, thanks for staying. So a small gift to you is that if you're new to Kafka, whatever, here's a coupon, free coupon to my Kafka for Beginners course. So feel free to just use the coupon or take a picture or use the QR code or whatever. But I'm really thankful for being here, and I do appreciate people who take their Wednesday night to just learn something. So that's my gift to you. Just do the course. It's 8 hours long, so maybe you'll hate me after this, maybe you'll love me.
Can it be faster?
Huh?
Like 8 hours. It's decades old.
Yeah.
4 hours.
No, 8 hours is a lot of content. You're not getting bored, and that's just one course. 7 courses, 35 hours. So there's lots to learn in Kafka, and I can talk about it for ages. But that's just for you. If you don't get a picture of this, Zagreb Meetup is the code for this. So go on the URL. So let me just show you what it looks like, just so you get an idea of what it is. For those who've never seen it, and it's not like an ad. I just want you to understand the business problem. And slash Apache. Sorry.
Shift 7.
Here. Okay, so it should work. So this is just my course, and so as you can see, there is an average rating right here, 4.6. There's number of ratings, there's number of students, and if you scroll down all the way, they give you like a nice histogram of ratings, and they give you like a live stream or some sort of information around people, what they posted and what they said. Just to give you an idea of like the type of data we're going to be using. There's a REST API, so I'm able to access all that data pretty easily, and it's not protected, so I can access it as much as I want, which is kind of cool. Okay, and so if you want to just use the coupon, then you put it here and you put Zagreb Meetup and you get it for free. Okay, so back to the presentation.
Sorry, you can run it in presentation mode. I think you have new.
There's presentation
I
mode?
think. Right.
Where is it?
It's a main menu, and you, then something.
Okay.
F5.
Okay.
Okay. Okay.
Nice.
It's getting good.
I know my.
You were feeling disturbed. You were feeling a bit disturbed by that left. You guys okay? Alright, good. I'm happy. I'm happy you're feeling
Now you can
comfortable
continue.
Now we can continue.
Look
Look at this. Okay, so this is what Kafka is. So for those who don't know anything about Kafka, Kafka is called a pub sub type of system. Now people call it a streaming platform. Call it an actual thing or a marketing term, I don't know. But this is the idea. You get all your data coming from different sources, very various. It could be websites, pricing, financial transaction, user interactions, server logs, like literally anything that happens and that generates something, some data, is a data source. And so the idea is that that data source, you want many applications to be able to read from it. Many applications. Could be 1, could be 20, could be 100, right? And so it could be a database, analytics, could be an email system, could be audit, could be a lot of things. And so the idea is that all this stuff goes through Apache Kafka. Apache Kafka is dead simple. It's a giant pipe. And it turns out that that giant pipe, on top of being giant, it's able to be distributed. So you can add pipes on other servers to make it a huge pipe. And that's what makes Kafka good. At its core, that's what it is. It's a giant pipe which allows data to flow through. And that may seem so simple, but it's actually very hard to do at scale. And that's why people are really into Kafka. But Kafka is not an end in itself, it's more of an enabler to say, okay, now we have our data streams in Kafka, and shopping carts, oh, what do you want? I want this, this, and that. Okay, I'm going to pull all this data real time and do something great with it. Okay? So Kafka is that kind of thing that allows you to self-service yourself. That's okay? Does it help for those people who don't know about Kafka? Alright. So, now, assuming you guys are familiar a bit with IT, so this is the kind of like, I showed you the website of Udemy. And so when you think about it, okay, I would say, okay, how do I reverse engineer a process? What does a review look like in their system? Like what sort of pathway does it do? So there's a REST endpoint, and everyone knows REST. A REST HTTP endpoint. There's a post that's done to a root. And so okay, I'm posting a new review, and then I'm assuming that this review goes into a database, Postgres, MySQL, whatever you want, Oracle, and it's called a table called all new reviews. It may be the most dumb design, it's just me, don't judge me, all new reviews. And then there is a fraud detection job that actually happens every 24 hours, which takes all these new reviews and does some kind of algorithm on them. Could be easy, could be complicated. Basically, maybe looking at user behavior. Is that user posting 10 reviews in 24 hours? That looks suspicious. All 1 star, all 5 star. Is that user using a free coupon, or is he paid for it? Has he been a long time user of us or not? Could be taking different things. But basically, when that fraud detection job happens, it figures out what is a fraudulent review and what is a valid review, and you make 2 tables of it. And then when it's happy, there's a statistics jobs that looks at all the valid reviews. We'll pull them all, like think Spark, think like MapReduce. Pull all the reviews, and we'll compute all time and 90-day stats. So it could be a lot of data, right? We're talking 100,000 courses, 30 million students. So it could be a lot of data. And you're still doing this job, and it runs, maybe there's like a way to orchestrate, maybe there's a way to orchestrate these jobs together and have them one run after the other, all that kind of stuff. Anyway, when it's done, it's going to make course stats table, maybe 2 tables, maybe 1 table for recent or all time, and then we get a REST endpoint to get the reviews or get the course landing page, and you get what I showed you before. Make sense to everyone? Maybe it's better than that, but that's how dumb it could be, right? So this is batch, right? We can see it all, it's batch. The batch thing in there is the fraud detection job, happens every 24 hours. And there's this orchestration aspect of it. This job runs after this job, right? By the way, if this jobs fail, then wait 24 hours, because it's going to kick in again at some point, right? That's the kind of thing that happens. By the way, my database is down, the whole thing is down. This is the kind of weaknesses of this type of architecture. I'm sure there's a mechanism for your database, obviously, but give you dumb and simple ideas. So quick run about Kafka. So how can we apply this kind of sources pipe sinks to what I just showed you? So this is what we're trying to get to. And it doesn't look much different from what I just showed you. It's the exact same box placement. A bit of colors, a bit of logo, it looks a bit prettier, a bit more inviting, but this is the exact same idea. So we're going to visit every single of these applications. So there's 4 colors. I know the blues are a bit not too different, but the green one, it's called a Kafka Producer. So 101 of Kafka here, but when you produce data to Kafka, you have a Kafka Data Producer. And that's the source of things. Nothing happens in Kafka if no one produces data in it. So a producer could be as simple as there's a REST endpoint, push data, and then the whole job of the producer is to take that review, maybe make sure the data format is correct, push it to Kafka, and off we go. That may be the sole job of the producer. And from that, we have something called a review topic. So before we had a database table, and now we have a review topic. And that's what it's called in Kafka. It's not a queue, don't ever say Kafka queue, I will come for you. It's a Kafka topic. It's very different. So in the Kafka topic, the reviews topic, this is where all my reviews come. And maybe there's a lot of things that happen from there, but maybe one of these applications, reading from my reviews topic, is going to be a Kafka Streams job for fraud detection. So maybe it's relying on a machine learning model. And why Kafka Streams? Well, because it reads from Kafka, and then it writes back to Kafka, and that's where the Kafka Streams library was born. Kafka Streams library, the sole purpose of it is to read from Kafka, do some transformation, write back to Kafka. Okay, so if you hear Kafka Streams, this is what it does. If you're a Kafka Producer, it's from the outside world to Kafka. Kafka Streams within Kafka. Okay? just defining basic terms here. And then, again, we have this fraud topic and this valid reviews topic, and there's going to be another Kafka Streams job that's going to take all the valid reviews and compute stats. Maybe all-time stats, maybe recent stats for the courses, and it's going to happen in real time. Maybe one topic, maybe two topics, who knows, and right back to Kafka, so again, it's a Kafka Streams job. It doesn't have to be Kafka Streams, it could be Spark, it could be Flink, it could be whatever you want. But Kafka Streams is really well done and easy to use for that kind of purpose. Okay? And then, okay, we have our stats in Kafka, and now how do we expose it back to the users? How do we make it accessible to the outside world? I had a question before, like, should I expose my Kafka cluster to the world? No, you should not. Kafka cluster should be private. The way you do it is that you have consumers. The consumer consumes data from Kafka and usually puts it somewhere else. So a consumer is going to pull all that data and put it somewhere. That somewhere is going to be maybe a PostgreSQL database. And so the first API that was available was producer and consumer. Very simple, that easy, right? But they're very low level. They're not very easy to use. And so recently, as recent as 2 or 3 years ago, there's an API that appears, Kafka Connect. And Kafka Connect is basically a replacement for a consumer, at least Kafka Connect Sync, and make it a little bit more friendly to use and that easy to use because people realize that, you know what, people do Kafka to Elasticsearch, Kafka to S3, Kafka to Postgres, Kafka to HDFS, Kafka to whatever. Everyone wants to do the same thing. There's like 20 sources you can count them, sinks you can count them. So why not just make standardized programs for everyone to use? That's kind of the idea. So Kafka Connect was born. High level overview, right? But once it's in Postgres, we go back to our good old Spring Framework, REST API, and we serve it to our clients, and we're done. So we only change the backend, okay? But we've decoupled everything, completely decoupled. This database at the end is a read-based database, okay? And on top of it, we've exploded all the data streams. So many applications can plug in to all these topics and view the streams and do whatever they want. Maybe you want to archive all the data into S3 or Elasticsearch to make it searchable or whatever. Whatever you want, you're free to do it. It's all in Kafka. It's available. Okay, so far so good? Does it help? It's like you've just seen all the APIs in Kafka in like 5 minutes, which is pretty impressive. But that's how Kafka works. And it could be overwhelming, like wow, there's so much, but it's actually pretty easy. So what I described is 4 applications. So when we talk microservices, we're like, how can we separate concerns? How can we separate teams? How can we think different jobs? This is the kind of things, right? There's going to be a team whose whole purpose is to produce Kafka reviews. A team whose whole purpose is going to design an algorithm to detect which reviews are going to be fraud. A team whose whole purpose is going to make a job to compute statistics, however complex or simple they may be. And a team whose whole purpose is going to feed their web architecture in any way they want. They could use Postgres, they could use MySQL, they could use Elasticsearch, they could use whatever they want. They're free to do so. So you have like 4 teams working together in a nice way, but all decoupled. So, first application, and we're going to view each application, and we're going to do a bit of hands-on, bit of demo. Again, don't focus too much on the code, focus on like the ideation of what comes through, okay? So the first one is the review producer. So turns out I can't really create a REST endpoint and start submitting stuff to it, like I can't fake the Udemy website. So instead of faking a REST endpoint, I'm going to use the Udemy REST API and fetch all these reviews from them. Basically scrape it and fetch all the reviews and put them into Kafka. So my producer is a for loop. Ask the REST API, can you give me the reviews? Yep, here we go, put them in Kafka. Can you give me the next reviews? Yep, here we go, give me in Kafka. And there's like over 6,000 reviews, so it's going to run for a bit of time. Okay? Ready? And let's just talk about this one as well, actually. I'll go back to presentation mode. Don't worry. So we're back in presentation mode. So the other thing is, a producer is nice, but I haven't really talked about the data format of producing data into Kafka. So who can name me data formats? Throw stuff at me.
Jason.
Jason, number 1. Come on.
Protobuf.
Protobuf, number 2.
Parquet.
What is it?
Parquet.
Parquet? Okay. Parquet?
Avro.
Avro, obviously, it's right there, isn't it? Yeah, it's there. And plain Java serialization. I like it. This is wild. This is the kind of guy who doesn't allow anyone to. I like it. CSV? Oh, what is that one? Okay. Excellent. Alright. He wants to crash Kafka. But you get the idea, right? You get different data formats, and each format we just named here, you can see my reaction. Right? Each format that was said to me triggered something in me. Like, I thought about, is that format the right format for Kafka? Is it the right format? So the first one was JSON. Right, JSON is pretty natural, right? We can read it, we can write it, we can look at it, makes sense. It's pretty verbose. Like big JSON documents, maybe arrays, start repeating a lot of keys, there's a lot of repeated information.
But we can use compression.
But we can use compression. We have a Kafka expert in the room. We can use compression. It's a nice one. Okay. What about data types? They're not really enforced. Right? I can make a field a string, and next thing I can make it an int. JSON won't complain about it. Maybe my program will. There's a concept of schema. Yeah, there's JSON schema, but is it really part of the data itself? Not really. It's not part of the specification. It was added on top of it. So it's a good first candidate. To be honest, lots of companies use JSON. It's web native, so we have a web application where I not push the JSON I receive to Kafka and be done with it. End of my story. That's fine. If you're 5 years, may become a problem. Then I heard Parquet. Not an expert in Parquet, but my understanding is that it's a columnar format. And so in that way, it's great when you're sending like a lot of data and it's meant to be read as a column. But Kafka is more of a per message row type of format. So Parquet is not a great data type for Kafka. Then I heard about Avro. I'll come to Avro in a second. Then I heard about XML. XML, yeah, XML, there is a concept of schema. They're horrible to write, but there is a concept of schema. Talking about verbose, if JSON is verbose, like XML is like an opera. It's, as long as that's good. Anyway, it's really, really verbose. You can surely compress it. Libraries to parse XML are this horrible. Then I heard something about Java serialization. I'm not sure about the efficiency of it. Maybe it's very efficient. But inter-language operability, not very good. Ask a Python developer to just read your Java serializable content. They'll give you the finger probably. And then finally, I'm just developing pros and cons, right? And then eventually there's Avro, and Avro is kind of good in between. It looks like JSON. It reuses a lot of concept from JSON. It has the concept of schemas. You cannot do an Avro payload without a schema. There needs to be a schema. Avro is actually pretty verbose. When you write a message, you need to write the message with that schema. And that schema may be huge. So if you write 1,000 rows as part of 1,000 different messages, then you need to write 1,000 times the schema. If you pack all these messages into one small big message, then just one time, right? But it's pretty verbose as well. But it has data evolution. You can make data evolve over time. It's pretty nice. And so the big problem with Avro is around that schema. It's so big. It's so big. Because there's documentation, there's comments and whatever. And you want to make it big. You want to use the schema. But so Confluent, they came up with this thing called the Schema Registry. And they said, wait a minute. Your schema, it doesn't change that often. Change it once a month. Maybe once every 3 months, once every year, once every 2 years, whatever your frequency of adding features is, right? And so, why don't we just externalize that schema into its own registry, and each schema will have an ID, and you just store that ID into your message, and off you go. And so that's where the schema registry came from. So in Kafka, you get three big type of message formats: JSON for those who don't care, Protobuf for those who are okay using it and for a short period of time, and then Avro for those who like the way Confluent is thinking and use the Avro schema registry. So your producer now will send the schema to schema registry, will modify the message into making it a thing that's not really Avro but looks close enough to Avro, send that to Kafka, and your consumer, when you receive that message, it's able to look up the schema ID from that message that looks like Avro but not exactly, retrieve the schema from the schema registry, and reconstruct the message from it. And because the schema doesn't change very often, your producer doesn't send the schema every time to the schema registry, and your consumer caches the schema on its end. So the only time there's REST interaction is when the start stops or when there's a schema change. So very efficient. So efficient in size, efficient in evolution, efficient in a lot of things. So Avro is a great data type for Kafka, and that's what I'm using for my presentation. This is the only way I'm doing this, okay? But if you don't use a schema registry today, wait until you get a production outage because someone added a field or modified a field type, and then you use the schema registry the next day. I promise you. So far so good? Any questions? Alright. Yes?
How is the support of libraries regarding schema registry?
Good. Confluent, and so this is made by Confluent. It's not a Kafka official component, it's an open source Confluent. Confluent, by the way, is the private company behind Kafka. So they're, I don't know if they're written on the t-shirt, but it's the private company behind Kafka. And so they just raised a lot of money, they're worth $2.5 billion. They're a big company, they spun out of LinkedIn, and they basically write open source and open core, I should say now, open core components and private enterprise components for you to use and buy a subscription from and get support and that kind of stuff. So their business model was to make Kafka used by you and supported by them. Okay? And so the question was, can these messages be read by other libraries or other languages than just Java? Because Java is first class support. And the answer is yes, Confluent has made a tremendous effort into saying to all their customers, oh, you want Node? Yeah, I'll give you Node. You want Go? I'll give you Go. You want Python? I'll give you Python. So they've made a set of libraries that are actually really good and working with all these languages. Okay, so it's good support, really good support. I'm not sure about Rust and I'm not sure about other darker languages, but overall it's good. Okay, so who wants to see a Kafka Producer working? Okay, so this is the project. It's on GitHub. You can check it out. I'm going to try to make this as easy as possible, so I'll make someone feel really nice today. We're going to presentation mode again. Okay, so we're in presentation mode, and so if you're just getting started, you just download Confluent from the website, and then to start Confluent, you do Confluent start, and it will basically boot up Kafka. It's very easy to get started with it. So I'll just do it. I think you can do it like this. Terminal. Okay. So I'm just going to start Kafka in there. Great.
I will not start the trade, so I'll help you. That's my computer. I don't have anything enough, but
Bin. You see? That's okay. Oh, okay.
So now you know.
Okay. Yeah. Okay. I'll okay. So hopefully this will work. So you do bin Confluent start. Yeah, it's working. So it's starting Zookeeper, one Zookeeper, then it's starting Kafka, one Kafka, it's starting Schema Registry, what I just talked to you about, and then it's starting Kafka Connect. I'll show you later, okay? So one command is happening right here, and it's just booting everything up for me. So far so good, right? Then, in Kafka, I said there are topics. Topics is like a table and database. So we have to create them. So we're going to create topics, and we'll create 5 of them. It's basically all the topics I showed you in that diagram. And you can name it actually however you want. The only thing you have to specify is number of partitions and replication factor, and then Zookeeper, where it is. So number of partitions is basically how distributed you want your topic to be. Replication factor is how durable you want your topic to be in case of failures of Kafka brokers. How many times you want that to be replicated. And Zookeeper is basically an old thing that needs to be there. So we'll just, that's how this
can be changed on the fly.
Sorry?
These parameters can be changed on the fly.
Yes, you can change them to whatever you want.
On the live system.
Yeah. Yeah. So, oops, I think I missed it. So I'm going to copy this.
But you should go to this Confluent bin directory.
Yeah, absolutely. So I'm going to the bin directory. Bin.
Yeah.
One. And okay.
You probably need.
Yeah, I'll probably need ls. All right.
Oh, maybe not.
Give me a second. I'll look at it. I'll do it. Get there with me. So this is going to create 5 Kafka topics. I'm going to run all these commands right here. So copy and right click, paste. Okay, and this is creating 5 topics. So this is working in the bottom. You can all see, right? Okay. All right. So then we were pretty much set up. So now I have this project. And so you saw before it was like a bunch of Java classes. I assume you're all Java developers or somewhat know Java. I use Maven, so I'll just use Maven clean package, and this will basically pull all the dependencies. Great. I'm going to run a journal. I'm going to pull all the dependencies and build the thing, test it, build the thing, and hopefully create jars for me, and I can use this jar. I could be lazy and just go from IntelliJ, but this is also a nice way of doing it. Okay. So we're good. So now I'm going to go to my first of these, okay, this, alright, so here. So this is 4 terminals that I have, and they're just going to be consumers. So we're going to start up a consumer on the first topic, and I need to move. Sorry, just lazy. What? Oh, okay. And then bin. Don't worry about it. It's not working. So I'm just adding the Kafka banners to the path so I can be done with it and run the commands from each terminal. So this should be good. Okay, and then I'm going to be able to copy this here. Copy. Paste. Okay. Paste. And that should make the trick. Okay. Alright, so let's get back to it. So I'm going to start my first Avro console consumer. So here I copy this, and here, yay! Alright, first Avro consumer. So it's going to consume from my topic named reviews. They're getting me reviews, and nothing's happening because I haven't produced anything. Make sense? Alright. So now we're going to do our first demo and start pulling reviews. So I export the course ID, and then I run this Java command to run my jar. And this basically pulls in 6,000 reviews from the internet into Kafka, and that will give us a nice data set to work with. Okay? So fairly simple. I'll paste this here. And I'm not in the right directory, so I'll do it again. And I'll paste this here. And here we go. So if the internet is nice, here we go. So we see like all the log from the application pulling in reviews. They're all in the Avro format, even though it looks like JSON in the UI. And my first consumer is pulling data. Okay. Thank you. Okay, so this is going to go on for a while, but if we stop on one, or we can't really stop on one, you see there's an ID, a title, content, it's gone. There is a rating, there's a user, there's a course, there's a URL. It's just a bunch of data you get from the internet, basically. Okay? Okay, let's just assume this is what. Next. First application down. So now we have all data in Kafka. Presentation mode. Alright. So we have all the data in Kafka, it's in reviews. Now we have Kafka Streams. And so, as I said, Kafka Streams is for doing Kafka to Kafka transformations. So that's what we're going to see next. And so here, we're going to run a simple fraud detection application. This fraud detection application is going to get a reviews topic, it's going to apply the latest AI neural network binary search classifier on my data. It's an if statement, and it's going to output data into two different topics. The if statement fails 5% of the time, and that's going to be a fraud. That's it. It's my best. So that's what it's going to do. So if we look at this application right here, and we actually, I'll exit the view real quick. So it's still going on, the thing. No. Exit presentation. Okay. So if you look at our project, and we look at the thing called Udemy Review Fraud. So just to show you how simple a Kafka Streams application could be. So it's a main, and I'm going to go back into presentation mode. So here's the main, and so we're basically defining a config. We're creating a topology, which is defining how this data will move and be transformed. And then we start the stream, and we say stop it when I stop my program. So the stream configuration, we specify an application ID, which is going to say what's my application name. It's very important in Kafka. Bootstrap server, which is where are my Kafka brokers. Auto reset offset, which is where do I start reading from. And earliest means you start reading from the very beginning of the time. So from the first data I've produced. And then this is just to not use caching, so it produces faster. You can have something called exactly once processing in Kafka Streams. That means that each data get only processed once. It's a new type of guarantee. Don't argue with me on this. Use the internet for that. And then schema registry information. And so if you look at the actual topology of our application, it's super simple. You have a builder, and the builder gets a stream, and that gives you a stream of review. You just say what topic you want to read from, boom, you have a stream of review. And by the way, now you say, okay, I'm going to have branches, and the first branch is going to be a valid review, like is it a valid review or not, and the second branch is going to be everything else. So is valid review is my deep learning algorithm, and it is a hash function, and it's if the hash is greater than 5, then that means it's a great review, else it's not. So very simple, it's just going to take 95% of valid reviews, 5% of fraud. But it could be a very complicated algorithm. Then I'll say, okay, my first stream of my branch is my valid reviews, the other stream is my fraud reviews, and peak is just so I can print it to the console log and make it seem like my program is doing something. And then I say, okay, 2 is put it into Kafka at this topic name. Super simple, you could draw it, that's what I showed you. And yeah, and then so when this is working, we go back to terminal. Actually not this one, we go back to run.sh. And so we're going to run this application. And so for this, first we're going to start 2 Avro console consumer. So the first one is here. The other one completely disappeared. Alright, still going. So I started 1 Avro consumer on the right hand side for my valid reviews. And then I'm going to start another one. And it's for my fraud reviews. It's going right here. Yeah, it's my fraud. And so they all started. Again, they're not doing anything because I haven't started my Kafka Streams application just yet. But that's going to happen right now. And so here, I'm going to launch my application, and hopefully things don't crash. Fingers crossed. Nope. Terminal. Okay. And this one's still running, so I'm going to start a new program. Right click, paste, and here we go. So my application is starting, it's doing valid fraud, just to show you that it's actually doing something. And so it was really quick, it's already done. But as you can see here, basically both consumers receive something. So bottom left, fraud, top right, valid reviews. Okay? Number 2 down. 2 out of 4. Okay. So now we have our review aggregator thing. So this review aggregator is saying, okay, now I have all these valid reviews and I want to compute statistics on them in real time. So how do I do it? Well, I'm going to run a Kafka Streams application, but Kafka Streams doesn't just do the simple, take this, divide it in 2 and put this in there. That's very simple. It does way more. It does windowing aggregations, joins, all the critical stuff. And so here, I have my core statistics, and I'm able to do some stateful type of aggregation in distributed mode at fault tolerance. And that's the kind of cool sell for Kafka Streams. It's not just a library that takes from here and put it here. It does aggregations and distribution and windowing, distributed fault tolerance exactly once. So the idea is that the state of your application is stored in Kafka, and so if your application needs to retrieve its state, it'll retrieve it back from Kafka and keep on going. So we're going to do an aggregation. This program is way more complicated, so I won't show it to you that much, but the idea is that out of it, we get a long-term stats topic and a recent stats topic, which just shows us basically what's going on. Okay? So I'm going to stop this one because otherwise we're black screen real estate. Let's go back to this. So we're going to get back to our run.sh file. And we are going to start 2 more consumers. So one on my recent stats topic, so right here, and one on my long-term stats topic. Okay, and nothing's happening, we're no wide now. And I'm going to launch my other application and streams, and I'm not showing it to you, it's more complicated. But this one is supposed to aggregate stuff in real time, and I really hope it works. It crashed on me last night once, but who knows. So I'm going to go back to this. Come on, buddy. And it's not working. Yay. No, it's working. It's taking its time. Okay, so yes, because I have caching enabled. Anyway, it's caching, so it's not as fascinating. You see one thing coming out of it after 30 seconds. It's how long it took. But now we see like the recent stats and the long-term stats. And this is recent. If you look at the count reviews, it's 1, 2, 3, 9. So in the last 3 months, I've received 1,000 reviews. Whereas if you look at long-term stats, the count of reviews is almost 6,000. Remember that 5% of my reviews went to trash. Okay, otherwise it'd be the same result. So we see how it works. Okay, and so lastly, Kafka Connect. So now we have all our data. We've done transformation. We have real-time statistics on it. Right? Think of these as long-running applications. Okay, this is our batch once in a lifetime. It's long-running. So now we want to use that data, expose it to our services, feed some databases, and give it to the world. This is where Kafka Connect comes in. So Kafka Connect could be used for 2 purposes. The first one is called the Kafka Connect Source Connector, which, as its name indicates, takes the source of data and put it in Kafka. It's slightly different from a producer. I think it's a prettier API. But the idea is, okay, you have a Postgres database, expose all the data in Postgres, put it in Kafka. And it's meant to do that. And so people wrote connectors to do just that. People wrote very complicated connectors. And you can just use them. One command, and off you go. It's ready. And that's what makes it really, really powerful. And then Kafka Connect Sink is what you think it does. It takes data from Kafka and syncs it into target databases. And again, think of what I said before, there's like 20 targets or 30 targets. Smart people wrote these things, such as you don't have to write it and go through the pain they went through. So if you want a Kafka Connect Elasticsearch, you have it. S3, you have it. Postgres, you have it. You have it pretty much everything. Nowadays, every single technology that I know will develop its own Kafka connector because it's becoming a standard. So even proprietary databases, they will just say, okay, for my customers, I'll just give them a Kafka connector. So here, how do we do it? We have 2 topics, and we're going to sync that into Postgres table. And for this, we'll use a Kafka Connect JDBC sync connector. Okay, that's the last demo. So here we go. So let's go exit that presentation mode. Oh yeah, that's one thing you don't have, eh? Do you have any visual way of exploring exploring SQL databases?
Not just from IntelliJ.
Well, you're gonna show. Oh, there's.
Yeah.
Oh, sweet. Okay, I'll do it. I know it. It's on the right hand side. So, okay. So Kafka Connect, what does it look like? It's actually so simple, I want to show you what it is. So I'm going to go back to presentation mode. So this is Kafka Connect. So someone created a JDBC connector for me, and I don't need to write it, it's not something I wrote. And they just say, you put in the configurations and I'll do the rest. What's your name? It's cool, sync topic. What's the connector class? It's a JDBC sync connector. How many tasks do you want? Like, what's the parallelization? How many workers do you want? 3. What's the connection URL of your Postgres? Here it is. What's your username? What's your password? How do you want to insert data? Like an upsert, such as if there's a duplicate reads and updates the data. Primary key mode, record value, primary fields for the primary key, my course ID, sounds like a great candidate for a primary key. And auto create the tables, yes. How many, what are the topics you want to sync? These 2 topics. And is there a key converter I should know about? Yes, this one, string converter. That's it. So it's a bit tricky to get right, but that's it. Just configuration. And then, how do we run this? And this is when things hopefully should work. How do we run this? Well, we just run this command, at least in dev. We run this command, and we say, okay, why don't you start me a little connector? Oh, Confluent, so I need to go to something that's Confluent enabled there. I'm on top of it. And you can't load it. Ah, yes, of course you cannot. So, which one am I going to terminate? This one. Let's do it again. I said, okay, start this connector, and on the right hand side, you can barely see it, but it says, yes, I've started it. That's what it said. So how do we verify that is the truth? Well, we open up database. And so we're going to connect. Oh, and it's not, oh shit, no, it's not going to work. I forgot to start a database. So it's actually, no, it does matter because then the connector is going to crash and then I have no idea how to recover it. But let's do it again.
Sure.
Alright, so Docker is starting, Postgres is starting, and I have no idea if things will work. Let's try it, see how it works. So at first I'm going to connect to it using IntelliJ. I'm going to say, okay, I'm going to connect Postgres, the username is Postgres, and the password is Postgres, and that should work. Yeah, it's loading. So I'm in Postgres, and I have my database, and no, okay, so that should work, so now I should wait for public. So, let's try this again. Sync topic read conference. Download? Sync topics? I really hope this works. Okay, it's been unloaded, so I guess it will load it again now. Okay.
Wow.
Yeah. Oh.
We have schemas.
Schema, right? Yeah. Public, here we go. Hey!
Wow.
Nice. Hey! Wow. So, wait for it. We get 1 row. It's cool, right? It's working. But now we can do cool thing, right? Like it's 1 row, because I showed you 1 course and I had 1 thing running as such. But now we can do, I'll get it. And now we can do something really cool. We can start producing more data to it. And so I can start running all these things together. And it's going to run 3 different courses, one after the other. And go back to my terminal. And maybe this one. Yes. And I paste it. And here we go. So now it's going to have 4 different courses going to load one after the other. And so if we go back to this, I need to wait 30 seconds because one of my Kafka Streams application, remember, was caching it and stuff like this. And it's just an optimization I did. I shouldn't have done it for this presentation, but I did it. But the idea is that after 30 seconds, it's going to push it to the next topic, and then it's going to appear eventually in this database. So what I wanted to show you here, the takeaway is that like all my components have been running on this laptop independently, one after the other, and they're all working. Here we go, like it's here. They're all working together and updating this thing. But when you think of this architecture, it scales. Like each program does its own thing. Each program can be scaled independently. If one needs more CPU, perfect. If tomorrow I get 1 million reviews, that's okay. Kafka can take my 1 million reviews. If my processing takes more time, that's okay. I will just wait more time. But I'm not going to put my endpoint that receives reviews down. Because my endpoint is stupid simple. It just takes data and put it in Kafka. And that scales immensely. And think of like my Postgres database, right? My third one. So my Postgres database, what does it do? It just takes writes, very fast writes, right? Maybe I'm going to be smart and also batch these writes once in a while. But on top of it, it's just a database that was used for this one endpoint and give it a read for people who want to access the number of stats I want for my courses. And that's it. And I could change my strategy, and instead of using Postgres, I could use Elastic, Redis, or Memcache, or whatever you want. You're really free to choose whatever architecture. And if these guys, they want to change their database, it only impacts them. They're up to changing their connector, the configuration, but everything that happens in the back doesn't need to change. It's all the same. So it doesn't look that different from a diagram perspective. But from a mindset perspective, now we get a true separation of concerns, a true way of like, how do we scale to global scale or whatever, how do we scale to massive amount of data, and how do we optimize our infrastructure such as we don't say to the team, no, sorry, you can't use timescale DB because guess what, we don't use timescale DB in our data, in our infrastructure. Yes, you can. If you want to take care of it, you can take care of it. You're up for it. So that's the kind of things I want you to remember, and that's just a cool demo, and it just shows a bunch of stuff, but hopefully that gives you a better sense into what Kafka can do, why doing all of these things and all that stuff. Yeah, it's a bit more complicated than having one master application, one master database, but it does scale a lot more. So thank you so much, and I'll take any questions.
We are running a little bit ahead. So maybe if we can take questions to the lobby where pizza is getting cold and
I'm so sorry.
And beer is cold. I want to thank you again, Stefan, for coming here. I think that he deserves a big applause because this is a presentation that he did on a totally different computer with different OS. So this is also like all the world. Yeah. Thank you.